interesting. Let's make that 80 decibels so we can make it design a higher order filter. So I'm going to click Design Filter, and now you can see that Matlab had to generate an 8th order filter to do that. So again, I didn't have to know ahead of time what order I needed to do. I just needed to know that I wanted by 1,000 hertz for my gain to be down to at least 80 decibels. So let's zoom in and see if that worked. So zoom in on this part of the filter. So let's start in the pass band. So in the pass band, we can see that at so here's our pass band was 300 hertz, and we specified that in the pass band we wanted it to be no more than 3 decibels down. So that's good. We got less than 3 decibels of ripple in the pass band. So let's go and see in the stop band. Let's just zoom out and start over again. So we said that by 1,000 hertz we had to be 80 decibels down, and here you see that at minus 80 decibels it went through exactly 1 kilohertz. Okay? So you're guaranteed that by 1 kilohertz your signal is going to be attenuated down to at least negative 80 decibels. Okay, and you can, in that case we were basically matching the stop band. That's why it went through exactly 1,000, 80. You could also match it through the pass band, and you'll get basically the same filter, but the difference now is that at 300 hertz you'll hit exactly negative 3 decibels, and in the stop band, let's see, in the stop band at 1,000 hertz you're below 80 decibels. Okay, so you've basically you've met your minimum specification. So again, it's an 8th order filter. Okay, and you didn't have to decide if it was 8th order. You just let Matlab do its thing. Okay, so export back to the workspace. I'm going to call this filter 2. Export, and all right, let's create our data again. So let's see, fs equals dt t x, and finally we can generate our y, and let's plot it. And hold on just a second. So clear figure CC. Okay. So all right, we're ready now to export the signal back to Matlab. So we say export as an object. I'm going to call it filter 2. I click export. Here's my filter 2 in memory now, and now I'm going to regenerate my signal. So sampling rate, dt, time, oops, there's my x, and finally I'm going to filter my signal now using filter 2, and finally let's plot the results. Let's oops, sorry about that. Let's zoom in. So where is my zoom in? Alright, and now you can see that again I'm getting 0.707. The phase shift is totally different, but that's okay because I've got a lot more phase shift than I had before. So I'm not really going to worry too much about the phase shift, but again you can see that right at the cutoff frequency I'm at 0.707, so very happy with that. So let's just remove the data tip. Alright, so back to my filter. So the final thing I'm going to do is try to make a ripple filter. So let's go make a Chebyshev type 1, and I'm just going to say that I know that I want a 5th order filter. Same thing, 4800 hertz. Pass band is 300, and I want 3 decibels of ripple in the pass band. Design the filter. Let's take a zoom. So there's our ripple that we got used to seeing the other day in lecture. And you can see that right at 300 hertz we passed the 3 decibel mark, and I specified 3 decibels. If I wanted to, I could have said 1 decibel of gain. So let's try 1 decibel of ripple, and you can see in this case I got the filter that I asked for at 300 hertz. I only had 1 decibel of ripple, but we'll stick with 3 for now. I think that's fine. So there's my passband ripple. Okay, exactly as I want it. We'll export it as filter 3. Export, and I've still got my data in memory, so I don't need to regenerate my data. I just say filter X with now filter 3, plot it, and we can zoom in. So zoom in, and there we go. And once again, we should see that we're getting 0.707 right at the passband. Again, the phase is a little bit goofy, but let's not too worry about that because that's really just an artifact of all the poles and the ripple and what have you. Okay, so a little bit more than 0.707 at the passband. Okay, so if you get nothing else out of this, what I'd like you to get out of this is that you can use the filter command to replace a lot of the heartache that we were going through with generating these output signals in the first place. So the filter command just replaces, it basically just takes your input X, your filter, whatever you call your filter, and produces the signal Y, and you don't have to do any behind-the-scenes work. The other thing that you're getting out of this tutorial is that you can use the filter design and analysis toolbox to create the filter for you. So you don't have to go to any trouble of actually defining the filter in Matlab by hand. And you're certainly welcome to mess around with this. You can make band pass, band stop. There's really a lot of options. As long as you stick with infinite impulse response, you'll basically be dealing with analog filtering. All right, so I hope this was useful, and please feel free to send me any feedback. Thank you.